4.51. First, there's no such thing as really point. We don't say it. Mathematically, that's not the right way. When you write 4.51. This part is called, this piece here, it's the whole number. This is known as the decimal point. And the last one, this is the whole number part if you want to. And the 51, that's this group here, is the fractional part. Now, let me write some numbers here. Let's have this number. Let me actually even go beyond that. I'll go 1 and 5 here. Let me write that number. We didn't discuss to the right of the decimal point yet. We said the weight of this location, the weight is what? 10 to the power of 0, which is 1. That's why this is called the ones. The weight of this location, that's 10 to the 1. That's why we call that the tens. The weight of this one is what? 10 to the second, which is what? Hundreds. So what about to the right of the decimal point? This will be 10 to the minus 1. And what's 10 to the minus 1? That's 1 over 10, or tenths with a th. That's the tenths. When you see a th, that means that's 1 over 10. 10 to the minus 1, if you remember negative exponents, 10 to the minus 1 means 1 over 10. The weight of this location, it's 10 to the minus 2. That's 1 over 100. So this is known as what? Hundredths. This is 10 to the minus 3, which is 1 over 10 to the 3, 1 over 1,000. And this one is what? Thousandth with the th. What comes after thousandth? 10,000th. 100,000th. What's a thousand? Millionth. So there is no oneth. We start with tenth, hundredth, thousandth, 10,000th, 100,000th, and millionth to the right of the decimal point. I can make it bigger, but in our book, I don't know if you can see it right here. See a TH's? Tenths, hundredth, thousandth, 10,000th, 100,000th, and so forth. The decimal point, the correct way of saying it is say and. See that word and? That's why I said there's no such thing as point. We always say and. So this number, we had 4.51. We're going to tell you how we're going to read that. And that's coming up actually next. Changing decimals. First, before we do that, let's talk about how do we change decimals to fractions. We're going to take decimal numbers and change them to fractions. For example, I want to change 0.9. Couple of things. Some people like to put the 0 and others don't put it. Either one is correct. So 0.9, or if you just write 0.9, both means the same thing. When you look at the value of that, this is the tenth. The weight of this location it's 1 out of 10. So really the value of this fraction, if you multiply them, 9 times 1 out of 10th. The digit is 9 and the weight is 1/10. How do you multiply fractions? This is over 1. The top times the top, the bottom times the bottom. So 9 over 10. If I have 0.81, change it to a fraction. The weight of this one is 1 out of 10th. Let's make it 87 actually. The weight of this is what? 1 out of 100. So the value of that is going to be 8 times 1 out of 10 plus 7 times 1 out of 100. Each digit times its value. If you remember the order of operations, the 8 is written as what? 8 over 1 times 1 over 10th, which is what? 8 over 10. This will be 7 over 1 times 1 over 100, which is what? 7 over 100 from chapter 2, multiplying fractions. And now if you want to add them, we're still in chapter 2. If you want to add them, what do you need to do? Common denominator, which is what? 100. So I need to change the two bottom numbers to make them both 100. So to change the 10 to 100, you multiply it by what? By 10 and by 10. What's 10 times 8? 80 over 100 plus 7 over 100, which is 87 over 100. That's what that number is equal to. Now that's a lot of work to convert that. Yep, is there an easier way than going through all of this? And the answer is yes. I just want to show you what the correct answer is, so when you see them, go, yeah, it does work. So let's look at that. Let's take the first one. The shortcut says write then this number without the decimal point. So if you take the decimal point out, you're not going to write 09, because 09 is what? Just 9. You're always going to divide it by 1 followed by zeros. The question is how many zeros? We'll count how many digits you have to the right of the decimal point. How many do we have here? 1, that's 1 0. 9 over 100. Over 10. Next one. 0.87. Write the number without the decimal point, 87, divided by 1 followed by how many zeros? Let's count how many digits we have here to the right. 2. How many digits to the right? 2. Is that the same answer? So instead of spending 6 hours doing it the other way, we can take 30 seconds and there is my answer. Let me try.
So, excuse me.
Yes.
So why do you have to bring the 1 and not 2 zeros?
Well, if you did 2 zeros, can you divide by 0?
No.
It's not a number.
Okay.
Yep. So this one will be what? 149. Notice I dropped that decimal point, divided by 1 followed by how many zeros? 3 zeros. 5.03. Instead of just 0.03, it's 5.03. Write the number without the decimal point. 503 divided by 1 followed by how many zeros? 2 zeros. Yep, we count the digits to the right of the decimal point. 2 zeros. And the one thing I forgot to mention, because the other ones I'm okay, well, I'll leave it even to stay okay for now, because you always want to simplify your answer. So far I'm giving you ones you can't simplify. Soon enough we'll have you simplify. 0.0013. Write the number without the decimal point. So what would you have on the top? 13 divided by 1 followed by how many zeros? Try again. 4. 1, 2, 3, 4. Seven two 3.94. Write the number without the decimal point. Divided by 1 followed by how many zeros? 2. And this you have to simplify. Notice the last digit is what? Even? So you have to simplify your answer. Let's look at the last answer. See if I can simplify it. Made it big, I don't know why, but so by 2 this is what? 50 by 2. 3, 12 by 6, 1, 19 by 2 is what? 8, 19 is 9. 9 times 2 is 18, there's 1, that's a 7. So I divide the top and the bottom by 2. And my answer is 3, 6, 1, 9, 7 over 50. I can divide this number by 2. I can't divide that one by 2. I can divide this by 5. I can't divide this by 5. I can divide this by 10. I can't divide that one by 10. It's simplified. So that's my answer for that one.
Can you please go over the 5.03? How you got the 503 over 100?
Write the number without the decimal point. So the decimal point is gone. What do you have? 503, right?
Okay.
Divided by 1 followed by zeros. How many zeros?
2.
How many digits to the right of the decimal point?
2 digits.
2. 2 zeros. It's always the number of zeros equal the number of digits to the right of the decimal point. We don't care about the left. Notice here, how many digits to the right of the decimal point? 2. That's why you have 2 zeros. How many digits to the right of the decimal point here? 4. That's why you have 4 zeros. Okay. Quickly, I'll give you a color them to try. They don't take that long. How about you try 5.6? Try 1.39. Try 7.003. And maybe I'll do the last one, 0.875. The first one is what?
56 over 10.
56 over 10. Can you simplify that?
Yeah.
You got to simplify it by 2. This is what? 5. By 2, this is what? 28, is it? So 28 over 5.
So if there's an even number at the end, you simplify it?
Well, if you can simplify it. If it's even at the end, you can divide it by 2. Yep. Now again, if you write that as a mixed number, what do you think? Is it 5 and 6/10? Better be. Or 3/5 actually. 6 over 10 is the same as 3 over 5. Because you can simplify 6 over 10 to what? 3 over 5? It is 6 over 10, but if you simplify it, it turns to 3 over 5. 1.39, that would be what? 139 over what? 100. I don't think I can simplify that. This one. 7 what? 003 over what? Try again. 1,000. And the last one, 875 over what? 1,000. Now I know I can divide this by 5. If the last digit is 5 or 0, you can divide by 5. So let's divide by 5. By 5, this is 200. By 5, this is 137. What's 37 divided by 5? This is 7 times 5, 6 times 5 is 30. So 7. 7 times 5 is 35. That leaves me with a 2. 175. I know you can divide 175 by 75, right? But if you didn't see it, divide by 5 again. By 5, that's 3 times 5 is 15. The remainder is 2. That's 35. By 5, what's 20? That's 40. Divided by 5 again, that's what? 7. By 5, 8. That's 7 over 8. So if you keep simplifying that fraction, you end up with 7 over 8. And I bet you if you have a calculator, you go 7 divided by 8, you'll get 0.875. Okay, so that's the first part in this section. Again, section 3.1. We're still in the same section, comparing decimals. Comparing decimals. What does that mean? I want you to tell me which number is bigger. 0.59 or 0.6. Which one is bigger?
0.6.
Are you sure? Again, let's change the story. If you were working for a doctor's office and it says, can you take these 2 folders and put them away, please? And one of the patients is Haddad. First name is what? Joe. The second one, Haddad, and first name is Z. What would you do? You start with the first letter. Oh, they're the same. Second one, the same. Next one, the same. Next one, the same. Next one, the same. Next one, the same. Oh, J and Z, which one goes first? J before Z. Well, that's the same thing. First, these numbers are different sizes. You can always add zeros in either direction, to the right or to the left. So if you want to make them the same size, go ahead. Now, which one's bigger, 60 or 59? 60. Now you see it better. But the key to comparing fractions or decimal numbers, decimal not fractions, is you go to this digit. Oh, they're the same size, right? Can't decide. Go to the next digit. Which one's bigger? 6 is bigger than 5. So 0.6 is bigger than 0.59. We have this one, 0.83, and the other number, 0.8297. Which one is bigger? 83, because these digits are the same. You can't make up your mind yet because they're the same size. You go to this one. 3 versus 2. Which one's bigger? 3. Again, if you want to make them the same size, you can. Now you know 300 is bigger than 297. So 0.83 is bigger than 0.8297. By the way, that's a common practice. If my answer was 4.6000, you're going to see me just write that 4.6. Because putting the zeros at the end does not change my answer. Just like when I have 0.5, leading zeros don't do anything for me. So I can just write that 0.5. So leading zeros, lagging zeros are useless. You want to put them there, fine. You want to take them out, that's fine too. They have no value. You want to know the place value because they're going to ask you to round. And if you remember, the rule for rounding is what? 5 or more, you add 1. So round to nearest tenth. Tenth with the TH. 1.35. 2.7094. 3.6499. 8.7504. Nearest tenth. Which one is the tenth location? Tenth is the first one after to the right of the decimal point. These are the tenths. So what's the rule for rounding? You look at the digit to the right of that. If that digit is 5 or more, what do? You add 1 to this. So this becomes what? 1.4. Is that 5 or more? No. 2.7. Is that 5 or more? No. 3.6. Is that 5 or more? Yes. 8.8. And now all these numbers are rounded to nearest tenth. If they give you the same numbers, but they said round to nearest hundredth, you have to know the tenth, the hundredth, all of them. And I'll begin with 0.4, 1.4, 2.7094, 3.6499, same numbers. I just changed the first number. I want it nearest hundredth. Hundredth means how many decimal places? 2, right? 2. The top number is a problem for me. It doesn't have 2 decimal places. You can add as many zeros as you want to. It doesn't change the value of that. So this becomes your hundredth. So you look at the digit to the right. Is that 5 or more? No. So nearest hundredth, this will have to be 1.40. Nearest hundredth, I got to add 1 to this, 2 point what? 71. Add 1 to the 0. Nearest hundredth, that's 5 or more, add 1 to this. 3.65. And nearest hundredth, that's a 0, way below 5. And we just rounded the numbers to nearest hundredth. It could be 1,000th, could be 10th, whatever they want to do there.